Welcome to the Deep Dive, your shortcut to really getting up to speed. Today, we're taking a close look at the engineering side of Python. We're unpacking something called type annotations, a feature that, well, promises cleaner, safer code and less time spent debugging.
That's the plan. Yeah, our mission today is really to cut through all the chatter and just extract the vital stuff, the actionable insights from, the research out there on Python typing. We need to get clear on what they are, sure, but more importantly, why they matter right now, how they can give your code quality a serious boost today, and crucially, how you can actually start using them without getting totally overwhelmed.
Okay, sounds good. And we've got a clear plan for this deep dive. First, we'll really nail down the definition because there's a common misunderstanding we need to tackle right away. Then we'll dig into what we're calling the three killer benefits.
hmm
After that, we'll cover the essential tools you need and wrap up with a practical strategy, something low friction, for bringing these into your projects gradually. So, let's start right there at the beginning. Okay, let's unpack this core idea. If someone just walks up and asks, what exactly are type annotations in Python? What's this, the absolute essential thing they need to grasp?
The simplest way to put it is they're hints, explicit type hints that you add right into your code, usually on function parameters and return values.
Mm.
But, and this is the absolutely critical part, the thing you have to get, Python itself stays dynamically typed.
Oh.
The Python runtime, when your code actually runs, it completely ignores these annotations. They're just hints. They're not rules, not enforcement.
That distinction, that philosophical point, it feels really significant because you can almost hear someone, maybe a longtime Python dev, saying, look, my code's been running fine for ages. Why add this extra stuff if the interpreter doesn't even care? What's the comeback to that?
Well, that goes right to the heart of Python's philosophy, doesn't it? If you compare it to a language like, say, Rust, Rust makes types mandatory. They're checked strictly at compile time, right from the get-go.
Super strict.
Exactly. Python's approach is different. It kind of embodies that famous phrase, we're all consenting adults here. The fact that annotations are optional is key. It allows for something incredibly valuable, gradual adoption. You don't have to slam the brakes on your project or rewrite everything just to start benefiting.
So Python's basically trusting us, the developers, to use these hints wisely, mainly for these external tools, the static checkers, not for the compiler or interpreter itself.
Precisely. It gives us a ton of flexibility. And, the type system itself isn't trivial. It's actually quite sophisticated. The research we looked at really highlights the power you get from more advanced things like generic classes.
Okay, generic classes sounds a bit abstract. Can you give us maybe an analogy for that? How does that work in practice?
Sure. Think about a basic container like a Python list. Normally, a list can hold anything, right? Integers, strings, other lists.
Yeah, anything goes.
Right. A generic class lets you define that container more specifically.
Mm.
You could say, okay, this specific list instance is designed only for strings, or another one only for integers, but you're using the same fundamental list logic underneath. It allows you to write code that's reusable across different types while still getting that crucial type safety check.
Ah, I see. So reusable building blocks, but with guardrails.
Exactly. Guardrails provided by the type checker, not the runtime.
Okay, that philosophical angle, the optionality, is interesting, but it does beg the question. If the runtime ignores them, why actually bother? Where's the real return on investment for developers putting in this extra effort? We found three pretty compelling answers.
Benefit number one is probably the most direct, the most immediate win.
Mm-hmm.
You catch bugs before your code even runs. Since Python itself ignores the hints, we use these external tools, these static analysis tools. MyPy is the big one.
Right, MyPy.
Yeah. These tools scan your code base, they read the hints, and they can spot errors before runtime. Things like, passing a number when a function expected a list, or calling a method that doesn't exist on an object.
That's huge. So static analysis is like getting the safety net you'd expect from a strictly typed language, but without forcing you into that language's constraints. It shifts errors from like frantic production debugging
Yeah, the worst time.
to being quick fixes you patch before you even commit your code.
Precisely. It significantly cuts down on certain classes of bugs reaching production.
Okay, so bug catching is a big one. Let's move past that. Let's talk documentation. Historically, documentation is, well, often where projects start to fall apart, right? It gets outdated fast. How do type hints change that game for the developer experience?
Oh, they completely revolutionize it because they represent documentation that literally cannot lie, or at least it's much harder for it to drift out of sync. Traditional docs, in separate doc strings or README files, they almost inevitably get outdated.
Mm-hmm. Happens all the time.
Type hints, though, they live right there on the function signature itself. So they offer, I'd say, three main advantages, and they mostly center around your IDE, your code editor.
Huh.
First, as we said, they're machine readable. That's fundamental. Second, because they are, your IDE suddenly gets superpowers. When you hover over a function name or type the opening parenthesis to call it,
Mm.
your IDE knows exactly what types of arguments that function expects and what type it returns. So you get perfect auto-completion suggestions, really rich documentation right there in a pop-up without digging through source code or separate docs. It's not just about being up to date, it makes every developer instantly understand the function's contract.
Right. It's like interactive, living documentation built right into your workflow.
Exactly. Less context switching, faster understanding.
Now, this third benefit is maybe the most forward looking, connecting type hints to, well, the way software development is evolving right now. The sources we looked at pointed out a kind of surprising advantage related to modern AI tools.
Mm.
How are type hints helping us type for the machines?
Yeah, it's becoming clear that well-defined types are sort of critical infrastructure for AI and automation, working with code. Think about how an AI, like Copilot or other code generation tools, reads your code. It's trying to figure out the intent.
Okay.
When you explicitly type your functions saying this takes an integer and a string and it returns a dictionary, you remove a massive amount of ambiguity. You're telling the AI precisely what the inputs and outputs are supposed to be.
And that must make a huge difference in the quality of what the AI can do with that code.
Absolutely.
Repeat.
It leads to much better code suggestions, better AI generated documentation overall, and maybe even more critically, it drastically simplifies converting your Python code to other languages if you ever need to.
Ah, like porting code.
Exactly. Imagine needing to port a performance critical Python module to something like TypeScript or Rust. If your Python code already has clear type annotations, that translation process becomes massively easier. It could save hundreds of hours. You're essentially future proofing your code base.
Interesting. So better for humans now, better for machines now, and better for future migrations.
Pretty much sums it up, yeah.
Okay, I think you've sold me on the why. The benefits are clear.
Right.
Now, let's shift from theory to practice, from why to how. If we want to actually start using this stuff today, what's the main tool? What's the core piece of the Python typing ecosystem we need to know about?
Right. The undisputed champion here is MyPy. It's the main type checker, the de facto standard. And its popularity really comes down to its flexibility. The key thing with MyPy is its configuration file, usually called mypy.mini.
Mm-hmm.
Think of this file as like a strictness dial for your project. You don't have to go all in on super strict checking from day one.
Ah, okay. You can ease into it.
Exactly. Teams can start off quite relaxed, maybe just checking for the most obvious errors. Then, as the codebase gets cleaner and the team gets more comfortable with types, you can gradually dial up the strictness level in that mypy.ini file. And one other small but vital detail, if you're building a Python library that other people will use, you need to include a special empty file in your package called py.typed. Seems weird, an empty file, but it acts like a signal flare. It tells any type checkers used by people importing your library, hey, look in here. I've got type information included, so don't freak out when you check code that uses me.
Got it. That py.typed file sounds crucial for library maintainers.
Okay, but we have to address the escape hatch, right? We've all been there. The type checker is complaining about some code, but you know it's actually correct, or maybe you're dealing with some tricky third-party library integration. What's the official way to tell the checker, just ignore this line for now?
That's where the special comment hashtag type.ignore comes in. It's like the pressure release valve for the type system, but you absolutely hit the nail on the head with the caveat. You have to use it sparingly.
Right. Don't abuse it.
Definitely not. Every time you use hashtag type.ignore, you're basically poking a hole in your type safety net for that specific line. So you should treat it like a little piece of technical debt, maybe add a comment explaining why you ignored it, and plan to fix the underlying issue later if possible. Makes sense. And let's tackle a historical point of friction: forward references. I remember dealing with situations like circular imports or a class needing to refer to itself in a type hint. It used to involve putting type names in quotes everywhere, which felt clumsy.
Oh, yeah, that used to be a real headache. Dealing with those forward references, especially before, say, Python 3.14 or so, often require those annoying string quotes.
Big improvement now, though.
Huge improvement. Modern Python versions handle most of these cases, circular dependencies, self-references within classes much more gracefully, usually without needing the quotes anymore. This change alone removes one of the biggest little frustrations that used to put people off adopting types, especially if they worked with complex data structures or ORMs.
That's great news. Okay, so we have the main tool, MyPU. We know how to configure it, handle exceptions with type, ignore, and forward references are less painful. What's the practical boots on the ground strategy for actually adopting this? Because nobody's going to rewrite a giant legacy code base overnight.
Exactly. And the beauty of Python's approach is you don't have to. You can, and probably should, mix typed and untyped code, potentially forever. The sources we reviewed generally recommend a kind of gradual four-step approach.
Okay, what are the steps?
First, set a baseline. Any new code written from this point forward, add type hints. Just make it standard practice. Second, identify your critical modules, the core business logic, the riskiest parts of your system, and prioritize adding types there first. Focus your effort where it counts most.
Right, focus on high impact areas.
Third, for all that existing legacy code, the rule is simple. Only add types when you're already in that file making changes or fixing bugs. Don't go on a massive typing spree just for the sake of it. Touch it, type it. And fourth, crucially, before you start any of this, get the team to agree on the initial strictness level in mypy.adne and maybe a plan for gradually increasing it. Consistency is key.
So it really sounds like the strategy is less about achieving 100% type coverage immediately and more about managing risk, focusing effort smartly, and building good habits moving forward.
That's exactly it. It's pragmatic adoption. Hashtag tag outro.
All right, let's wrap up this deep dive on Python type annotations. We established their optional hints, not enforcement. That whole consenting adults idea is central. We saw the three big wins: fewer bugs thanks to static tools like MyPy, way better documentation built right into your IDE, and making your code more future proof for AI tools and potential language conversions.
Yeah, and tools like MyPy give you that flexible configuration, that strictness dial, while the py.typed file helps libraries play nice. And the strategy is all about being gradual, start with new code, focus on critical parts, type legacy code as you touch it.
Exactly.
And if you pull all those threads together, what's the ultimate goal? It really comes down to clarity. Investing that bit of effort in type annotations is fundamentally an investment in code that's just more maintainable and understandable, both for your future self, your teammates, and increasingly for the machines interacting with your code.
Absolutely. And, that brings us to a final thought, something for you, the listener, to chew on. Building on that trade off we mentioned earlier, Python gives us this flexibility, this gradual path to type checking, letting us avoid the huge upfront cost you see in strictly typed languages that demand correctness from the start.
Mhm.
So the question is, how might that very flexibility, the lack of mandatory compile time enforcement, ultimately shape the long term architectural stability and maybe even the development speed of large Python projects compared to their strictly typed counterparts? It's that classic tension, isn't it? Control versus convenience.
It really is something to think about.
Definitely. So,
Okay.
our recommendation: give MyPy a try. Seriously, install it today, run it on even just one small module in a project you're working on. See for yourself the immediate value you get from the improved documentation hints in your editor and the potential errors it catches right away.
Yeah, just dig your toes in.
Exactly. Thanks for joining us for this deep dive. We'll see you next time.